It is now a common knowledge that fingerprints are the most infallible means of identification. To identify a person, the rich characteristics on the fingerprints have to be used. These patterns are of three broad types: arches, whorls, and loops. Incorporated within those patterns are certain breaks, which we call fingerprint characters. Most of the times, the lines run parallel to each other. These ridges have been provided to us by nature so that we may have a firm grip of the object we intend to hold. In their absence, a glass of water will fall out of your hands 9 out of 10 times. These lines, which we call friction ridges also, they show breaks at many places, and as I said, these breaks are called fingerprint characters. They are of several types. Sometimes a ridge abruptly ends. It's called ridge ending. It was supposed to go further, but it stopped. Sometimes the ridge makes a Y. We call it bifurcation. At another time, there is a short independent ridge, nothing to the left and nothing to the right. We call it a short independent ridge. At times, a small curved ridge is attached to a main ridge. It is called a hook. Likewise, between two parallel ridges, if there is a small ridge joining them, we call it a crossover. Quite rarely, a ridge may split into three and we call it trifurcation. It may also happen that there is a small dot or a small circle in between the ridges. That's called an island. And lastly, a ridge, rather than going straight, takes a roundabout and then goes straight. That is called a lake. A person is actually identified on the basis of these fingerprint characters. According to Indian law, if the position of similar characters at 8 different places is the same, then the person is same, otherwise he is not. On an average fingertip, there are about 80 to 85 characters, but to identify a person, only 8 are needed, which means that even if 1/10 of the fingertip can be developed, it can still be used for the identification of the person. There are people who try to be over clever. They make a wire gauze red hot and then keep their fingertips over it, thinking that the ridges will be gone. They are actually not gone. Within the holes of the wire gauze, you can find 2 or 3 characters, and remember, a total of only 8 is required to identify a person. So on the basis of the fingerprint patterns, as well as on the basis of the ridge characteristics, fingerprint becomes the most useful mode to identify a person in crime cases as well as in peaceful cases. Suppose there is a case of drowning, suppose there is an air crash, the bodies are so mutilated that it is not possible to identify them. In such cases, fingerprint detection also helps.
Dear students, after studying this module, you shall be able to know the various kinds of fingerprints, identify different types of fingerprint patterns, know the various ridge characteristics in a fingerprint, and identify different ridge characteristics in a given print. Now, let us start with introduction. Look at the tip of your fingers. You could see the innumerable lines crisscrossing and making spherical shapes. These lines are commonly referred to as ridges, and their pattern make a fingerprint. Fingerprints are an impression or mark made on a surface by a person's fingertip. The study of finger impressions is referred to as dactyloscopy. Dactyloscopy originates through the Greek word dactylos, signifying finger, and scopion, to examine. Fingerprints are the most widely used human characteristics for the identification of an individual. Although loops whorls, and arches together with deltas and cores provide an effective means for classification of fingerprints. But the identification of the impression depends on the finer aspects confined in ridge patterns. The area of the hand, that is palm, and the area of the feet, that is sole, are enclosed within two entirely different classes of marks. The least noticeable marks, but the most abundant by far, are known as ridges. If you see your own hands, you will notice that it is superficially covered with tiny lines commonly referred to as ridges. Ridges enclose entirely palms and fingers of your hand and the sole of your feet and toes. They are known as friction ridge skin, as skin on these areas of the body is different from that covering the rest of your body. It mainly helps us to grip things. We will observe that the ridges from patterns substantial in magnitude and of an exquisite diversity of shapes, whose margins can be definitely outlined, and which are little worlds in themselves. They have the unique virtue of retaining all their peculiarities unchanged throughout life, and offer, in consequence, an incomparably unquestionable criterion of distinctiveness than any other bodily feature. You already know that ridges and valleys make a fingerprint pattern in a manner that valleys are placed in between the ridges. In this module, you shall learn about the different types of ridges characteristics which are referred to as minutiae. The ridges once established do not change with age and are totally unaffected by the environment. These features are present in the friction skin ridges, which leave behind impressions of its shape when it comes into contact with an object. The impressions from the distal phalanges are called as fingerprints. The ridge characteristics serve to individualize a person. The science of friction ridge skin inspection, which is grounded on the premise that the arrangement of friction ridges is unique and therefore can be individualized to a single source of origin, began as an observation more than 300 years ago. Fingerprints have been used for forensic identification purposes due to features within their patterns called ridge characteristics or minutiae. Now, let us have a detailed look on fingerprints. Fingerprints are the suggestions of an impression from the friction ridges of any part of a human hand. Though it is true that each fingerprint is different from the other, yet it is also true that all fingerprints have common characteristics among themselves. These common characteristics are what make fingerprint classification possible. The fingerprints may be categorized into three general pattern types, that are arc, loop, and whorls. The common characteristics that make up these patterns are known as pattern area, type lines, delta, and core. Now, let me tell you something about pattern area. Pattern area is a part of a loop or a whorl where appears the core, deltas, and ridges that are primarily responsible for classifying fingerprints. It exists in all patterns, but in most arches it is indefinable. Type lines enclose the pattern areas of loops and whorls. Now, type lines are the ridges that determine the pattern area of loops and whorls. The arches lack presence of type lines. These may be well defined as the two innermost ridges starting parallel or run parallel to each other, then diverge and tend to cover the pattern area. They do not form two continuous ridges. In fact, they are frequently seen to split apart. Then comes delta. Delta is formed when a ridge bifurcates and two arms of the bifurcating ridge diverge, or when two adjacent ridges running side by side diverge, causing an interspace within which the pattern lies. Next is core. Core is the central point of the pattern. The core is approximately the center of the finger impression. Now, let us see types of fingerprint patterns. Fingerprint patterns are determined by the arrangement of the ridges present on the distal phalange of the finger. There are three basic pattern types: arches, whorls, and loops. Now, let me explain these basic patterns. First of all, we have arches. The pattern type in arches are plain arch, tented arch. In case of plain arch, the symbol is A, and for tented arch, we symbolize it with letter T. Then comes loop. The pattern type in loop are radial loop and ulnar loop. Symbol which signifies radial loop and ulnar loop are capital R and U respectively. Then comes whorl. Now, whorl has plain whorl, central pocket loop, double loops, and accidental whorl. The symbols that signifies them are capital W, C, S, and X respectively. Now let us have a detailed look about arch. Arches are found in about 5% of fingerprint patterns encountered. In arches, the ridges of the finger run continuous from one side of the finger to the other with no recurving. It is imperative to state that the arches show absence of the any above discussed patterns, that is type lines, deltas or cores. There are two subgroups within the arch pattern. A. Plain arch. This pattern has a steady flow of ridges. It begins from the one side of the finger and then the ridge flows upward marginally, almost like a wave. The plain arch then continues its strip along the finger to the other side. Next is tented arch. This pattern is similar to the plain arch. It begins on one side of the finger and glides out in a similar manner to the other side. However, the dissimilarity lies in the ridges. In a plain arch, the ridges are continuous, while in tented arch these are not. The ridges which connect each other in the center meet and thrust upward, giving the imprint the shape of a tent. Now, let us discuss loops in detail. The most common of the three general patterns are loops. The frequency of occurrence of such patterns is 60 to 65%. A loop is a type of pattern in which one or more ridges enter either side, recurve, touch, or pass an imaginary line between delta and core and tend to exit from the same side as the ridge entry. The imprint on the fingerprint card is similar to the opposite image that we see when we look in the mirror at ourselves. Loop pattern has got two focal points, A delta and B core. Henry has identified two categories in this group. A. Radial loop. These are loops that drift towards the radius bone of the hand, or, in other words, when the downward slope or opening of the loop is from the direction of the little finger towards the thumb of the hand. It is referred to as a radial loop. Then the second one is ulnar loop, a loop pattern that streams downwards the ulnar bone of the hand, or when the descending slope or opening of the loop is from the direction of the thumb toward the little finger of the hand. It is denoted to as ulnar loop. Now let us discuss whorls in detail. The second most common of the three general patterns are whorls. The existence rate of such pattern is 30 to 35%. In whorls generally have more than two deltas. Delta is the first ridge adjacent to the divergence point of two type lines, and there exists a recurve before reaching each delta. There are four subcategories of whorls. Number 1, plain whorl. A plain whorl pattern possesses type lines and at least two deltas. It also has at least one ridge that makes a complete trip. This ridge may be in the form of a spiral, oval, circle, or variant of a circle. The plain whorl is the most common form of whorl and the mostly found. For a pattern to be a true whorl, it must be composed of two deltas comprising of recurve in each front. To help discern whether a pattern has two deltas and might therefore be a plain whorl. If they are joining, it indicates plain whorl. Draw a hypothetical line joining the two deltas along any one of the spiral ridges inside the delta nearest to the core. The another kind is central pocket loop. In these whorls, one or more of the simple recurves of the plane whorl recurves a second time. An illusory line can be drawn amongst the two deltas and does not cross or touch a ridge inside the type lines. One delta appears to be significantly adjacent to the center of the pattern than the other delta. Another kind is double loop. A double loop pattern, as the name denotes, is made up of two loops joined into one fingerprint. It comprises of two separate loop developments with two individual and different groups of shoulders and two deltas. Then comes accidental. These are certain composite pattern inside the world group as they arise infrequently and their existence is purely by chance or by accident. In these, the combination of the pattern is derived from two diverse kinds of forms with at least two deltas. Accidental worlds can follow in some of the arrangements as loop and a whirl, loop and a tinted arch, loop, and central pocket loop, and the last one, double loop and central pocket loop. Accidental whorls are very rare and unique and occur with a frequency of only 1 to 3%. The fingerprints depicted in figures are an example of an accidental whorl because these do not follow to any other definition, pattern, or category type. Now, let us have a detailed look on ridge characteristics. The palmar surface of the hands as well as the sole of the feet found both in men and monkeys are enclosed with minute ridges that possesses a superficial resemblance to those made on sand by wind or flowing water. The ridges are subject to certain breaks or interruptions presenting various kinds of characteristics referred to as minutiae. These minutiae are able to describe the invariant and discriminatory details and are helpful to identify fingerprints. The friction ridges have certain basic features which are present in sufficient number in every fingerprint. A single fingerprint may possess as many as 100 or more minutiae on a finger tip as depicted in the figure. These minutiae can be easily identified based on their shape or appearance. Each and every fingerprint comprises these rich characteristics, though it is their sequence that makes a fingerprint unique. They are also sometimes referred to as Galton's detail, as Sir Francis Galton was the first one to notice that the ridges on the fingers did not path in line without breaking, and he identified numerous ridge characteristics to support the identification of the fingerprints. The figure and positions of any particular finger, example, the ring finger on the right hand. The ridges on the feet and the minutiae differ from finger to finger in any particular person and from person to person, for toes are less complex and those on the hands and digits and are less helpful for purpose of identification. Now, let us discuss types of ridge characteristics. Number 1, ridge ending. This is a ridge which abruptly ends its path. They occur very abundantly in a finger impression. The second is bifurcation. It is a ridge which splits into two small ridges forming a Y shape. It is also known as diverging fork. They give an appearance of branch points between curved lines. These are also encountered very frequently in a fingerprint. Third one is trifurcation. It is a ridge which splits into three small ridges and it is a rare occurrence. Fourth type is interjunction. It is the joining of two adjacent ridges by a short diagonal ridge. It is also called a crossover. Fifth type is fragment or short ridge. It is an independent ridge of relatively small length. Then comes enclosure or lake. It is a ridge which first bifurcates and then converges or joins back to form an elliptical enclosure. It is also called as lake. It can vary in size. Seventh is island. It is a point or a dot within the overall pattern of a fingerprint. Then comes intersection or changeover. It is formed when two adjacent ridges change their place by crossing over each other. The ninth will be return. It is a ridge that changes its path and takes a U turn. Tenth and the last one is hook or spur. When a small curved ridge which is attached to main ridge forms a hook or a spur-like appearance, it is known as hook or spur. Now, let us have a look on formation of ridges. The embryological progress of the ridges has been considered extensively by Dr. A. Coleman. He conceived the ridges to be shaped through adjacent pressures between nascent structures. The ridges become noticeable in the third month of fetal life and are fully developed by the sixth. In children and babies, the fragility of the ridges is proportional to the compactness of their stature. They develop concurrently with the all over development of the body and remain to be sharply distinct until old age has set in, when an incipient disintegration of the texture of the skin spoils and may largely obliterate them. Now, ridges grow mostly in hands which do a reasonable quantity of work, and they are strongly developed in the foot, which has the capacity of supporting the load of the body. They are faintly developed in the hands of ladies due to manual labor. They are obliterated on the hands of laborers and artists due to pressure of their tools. Severe injuries tend to destroy hand ridges. Minor injuries do not cause permanent damage. A deep cut leaves a scar with puckering on all sides, making the ridges at that part undecipherable even if it does not wholly obliterate them. Now, let us summarize this chapter. So, dear students, in this chapter, we have learned that fingerprints are the imprint of friction skin ridges present on fingers and thumbs. Fingerprint patterns can be classified into three basic types that occur in different frequency, such as loops occur from 60 to 65%, whereas whorls occur from 30 to 35%, and arches are found in only 5% of population. Then we have come to know that arches shows absence of type lines, deltas or cores, whereas loops have got two focal points, A delta and B core, apart from distinct type lines. Then in this chapter we have learned that in whorls pattern types there exist two or more deltas. We have come to know that double loop whorls and central pocket loop whorls occur with comparable frequency of 13%, and about 70% of the whorls are plain whorls while only 3% are accidental whorls. Apart from that, we have learned that rich characteristics or minutiae are able to capture the invariant and discriminatory information and are used to identify fingerprints. And we have also learned in this chapter that there are different types of ridge characteristics, which are ridge endings, bifurcation, trifurcation, interjunction, fragments, enclosure, island, intersection, and returns and hook. Then we have learned that the individuality of any fingerprint is based not upon the general shape or pattern that it forms, but instead upon its ridge structure and its specific characteristics. Of all these minutiae, ridge endings and bifurcations occurs most frequently in a fingerprint. The ridges are said to be first discernible in the third month of fetal life and fully formed by the sixth. And lastly, we have learned in this chapter that the number and locations of the minutiae vary from finger to finger in any particular person and from person to person for any particular finger.